Hi everyone. So we will be solving the second question of DSA cracker sheet, which is find the maximum and the minimum of the element in the array. Let's try to understand question first. Okay. So first thing first, let's go to the question. Okay. So in this question, we will be given a array and we have to return minimum and the maximum of a array. Okay. So there's one more criteria which we have to see, that is we have to do the minimum number of comparison to get minimum and the maximum of array. Okay, before we move on, let's first understand how we get minimum and the maximum of a normal array with the normal set of comparisons. Okay, let's start. Okay, so let's start with the minimum. Maximum of array dot cpp. Okay, so first thing first, we will import all the basic header files. So we'll all the important one, which is bits standard c++.h. Then we will write namespace. Okay, so our basic setup is done. Now let's understand what is minimum and the maximum of array. Okay, let's take the example and understand. Okay, so for the example, we'll take a basic example of array. Okay, so let's say we have array 1 2 3 4. So this is a very fairly simple array that we have taken. 1 2 3 4. So the minimum of array is 1 and the maximum of array is 4. Similarly, let's take a complex one, okay, where elements are a bit randomly sorted. Okay, let's write okay, so we have to find the minimum and the maximum of array. So as usual, you will see 2 is minimum and 7 is maximum. Okay, let's understand, okay, how we can find this with the easiest steps. Okay, let's not focus more on the minimum comparison requirement. Okay, let's just focus only on the getting the objective correct. Okay, what do I mean by objective? Getting minimum and the maximum of an array at given point of a time. Okay, so the simplest approach for this is directly use the inbuilt library in STL and get it done, as we did in the last question or last video of ours. Okay, let's do it. So simply what we will do is basically we'll first ask user to enter size of array. Okay, enter size of array. Okay, once this size of array is entered, then we will ask user to enter the element of array. Okay, so once we ask user to enter the element of array, let's define the array. Okay, so we are using vectors to make to keep things simple. Vector of size n. How do we take input of array? As you seen in the last video, very simple technique: auto at the rate I colon array. Then how do we take input? C of I sin. Okay, so now we have taken the size of array input. We have taken the element of in the array. We have taken input. Okay, now let's do very simple implement very simple min or max function. Okay, so if you just go on Google, vector in cpp. Okay, so very simple function, we don't have to do much about it, just directly write this as it is. Okay, So let's define min. Okay. Array dot begin, comma array dot end. Similarly for max, max underscore element, array dot begin, array dot end. Fair enough. Fair enough. Okay. Now let's print this and let's see whether it is working or not. Okay. Okay, so fair enough. We are done. Let's see how it works. So let's run this. So as you can see, enter the size of array. Let's enter 5. Let's enter any random numbers. 10, 9, 1, 2, 4. Okay, let's see. The minimum is 2 and the maximum is 10. Let's align them properly so that we get numbers properly. Okay. Let's run it once again. Okay, this time I'll enter 8 numbers. Okay, 8 random numbers. So in this 8 set of numbers, the minimum is 2, maximum is 44. Okay, now let's decode this code. Okay, what we have written. So we have inbuilt functions in STL. So the name of function is min element and the max element. Min element is the function to find minimum in the range. Okay, range of array or range of element. Maximum element is basically to find maximum of a maximum number in the range of array. Okay. So what I mean by array.begin and what I mean by array.end is nothing but, let's say if I have array of size 8, okay, so what will happen in the size 8? So this is the 0 index, this is the last index. Okay, so I can also call the 0 index as array.begin. Okay, and I can call this end index array.end. Okay, so if this is the array.begin, then I can also write 7 as array.begin plus 7. Fair enough. So this is just the different way to write it. Very simple. So I have to find the minimum element between the first index and the last index. Okay, same maximum element between the first index and the last index. Fair enough. Yes. So this is how we are doing. We are finding the minimum and the maximum of our array using very simplest technique, simplest function in the STL. Okay. Now we will go one step further and we'll dig deeper into it. Okay. The easiest way to find the minimum and the maximum of array using STL function. Okay. Now we'll go one step further and we'll dig deeper into one more method, which is another very simple method. Okay. Let's see that method first. Okay. We'll first understand the theory, then we will write the code. Okay. So we'll do that. Okay. So everything will be same. We'll just comment out the code part. Okay. Now let's start working on this. Okay. How do we work on this? Very simple. Okay. Now we first start with the array. Okay. Let's take example of array. Okay. So let's take one array. This is the array with again 8 element. Okay, because 8 is a good number. 8, 5, 10, 1, 2, 7, 5, 6, 9. Okay, so our objective is to find the maximum number and the minimum number. Okay, so in this method what happens is we define two variables. Okay, first is variable min, second is variable max. We assign the maximum value which is available in the integer. Okay, so what is the maximum value available in the integer? I don't think you need to know this. You can either say 2 raised to 64 or the better approach would be we can go to Google and find it out. Okay, we are not doing any one of those. You can search on Google by yourself. The best way is to write int underscore max. Okay, so we'll define a variable min and we'll give the maximum value possible in the integer out there to this minimum variable. For minimum variable we have assigned the maximum value. Let's see what we can do for maximum, the variable called max. So for max variable we will assign the least possible value in the integer. Okay, how we will achieve that? Int underscore min. Fair enough. So we have a variable called min and variable called max. We have assigned the maximum value possible in the integer to min, and we have assigned least value possible in the integer to max. Let's see. Now the step 2 is iterate this array from 0 index to the last index. Okay, so array is of size 8, so it will go from 0 to 7. So how do we iterate? Simple, as discussed in the previous videos. I equal to 0. This is the normal iteration, right? I is less than n. Okay, and I plus plus. So after every addition it will increment the value of I, and then at every iteration we have to do two things. Okay, we have to compare the value of min. Okay, let's say the value of min is I'm just writing very large number. Okay, and max is very least number. Okay, so I'll compare the first value at index 0 with min and max both. Okay, so let's see. If I compare min with the this value, so tell me which one is greater. Definitely this one is greater, right? If this one is greater, sorry, if we will compare this min and the first index, tell me which one is greater. Definitely this one is greater. That means this one is smaller. So we will see if array of I is smaller than min, we will assign value of min is equal to array of I. Fair enough. Same we will do for if value of max is greater than the array of I. Okay, 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 let's start again. If the now let's take the example for max. Okay, so max is having a value -99. Okay, if I compare this one with this one. Okay, so let's discuss this with respect to the maximum value. Okay, so if I compare this maximum value with this one, obviously this one is greater. So I'll just write if array of I is greater than max. Okay, then what will happen? I'll just assign max equal to array of I. Okay, so we will do this on every index. Okay, so if I is equal to 1, then we will again compare 5 with the current value of min. So what will happen? The current value of min is basically nothing but 8, and current value of max is 8. Fair enough. For I equal to 0. Now for I equal to 1, what would be the value of min? Okay, we will again compare 8 with 5. Okay, so the condition for min is nothing but if array of I is less than min, we will assign min equal to array of I. So 5 is definitely less than the 8, right? So we will assign min equal to 5. For condition for max is if array of I is greater than max, so 5 is not greater than max, so again max would be same 8. Now for I equal to 2, what will happen? We'll again see min is 5, max is 8. So min is definitely less than 10, right? So min would remain as it is, which is 5. Let's compare max. So max is less than 10. Okay, so we will get new value for max, which is 10. Fair enough. Similarly, we'll do for I3. So max is 5 and this one is 1. So array of I is greater than, array of I is less than min. So we'll assign min equal to array of I, which is 1. Similarly, max. So max is 10, array of I is 1. So there is no change because array of I is not greater than max. So max will remain as it is. Okay, just 10. Similarly, if you do it for all the 7 iteration, you will get the output as min equal to 1, max equal to 10. Fair enough. This is what, and this is how it is going to be. Let's code this out and understand. Okay, so based on this experiment, we know the pseudocode steps. Okay, so first write the pseudocode. Let's write the pseudocode and then we'll code this out. Okay. Okay, so first we will write the pseudocode. And how do we write pseudocode? We have to write the step 1, right? Step 1 is nothing but define max and min. मैक्स को सबसे लीस्ट पॉसिबल वैल्यू इंट अंडरस्कोर मिन, मिनिमम को सबसे मैक्सिमम पॉसिबल वैल्यू इंट अंडरस्कोर मैक्स. Fair enough. Once this is done, second step would be the iteration. Okay, for 0 to n minus 1. Third step would be the comparison, and fourth is assignment. So comparison मतलब क्या? So if given array of I is greater than min, okay, sorry, if current array of I is less than min, so we'll assign min equal to array of I. Okay, if given array of I is greater than max, so we'll assign max equal to array of I. Okay, so this is what our assignment is. So let's code this out and let's see if code works properly or not. Okay, fair enough. Let's start. So we will define int min, which is equal to int underscore max, the maximum possible value which is out there, int underscore min, least value present in the integer. Fair enough. Okay, now the second step is iterating array. So how do we iterate is basically I to 0 n minus 1, and we will increment after every iteration. Fair enough. Once that is done, we have to compare our minimum mean with the array of I, right? And what is the comparison? If minimum is greater than array of I, okay, if minimum is greater than array of I, what will happen? Minimum would become array of I. Okay, fair enough. And if max is less than array of I, then what will happen? Max would become array of I. Okay, fair enough. So now we are done with the max and minimum. Let's see whether this code is working as we expected or not. Okay, we'll enter 8, 10, 8, 5, 2, 3, 4, 1. So minimum is 1, maximum is 4. So as you can see, 1 is the least value and 54 is the maximum value. Fair enough. So we have done it with the second method. Now let's go back to the question and let's emphasize on the one more condition, okay, which was we had to write a program should be able to make minimum comparison. Okay, so are we doing minimum comparison? No, we are doing all the possible comparison possible, right? Like we are iterating from 0 to the last index. It means we are covering all the possibility of comparison. Okay, so how we can avoid this? Okay, how we can avoid this? So very simple method would be okay, let's take a good example. Okay, let's take this example based on this the current code. Okay, what we can do with the help of this code and what we can't. Okay, first thing first, let's say if the array size is 1. Okay, if there is only one element in the array, okay, which is 1, so will this code work or not? Definitely it will work, but it will do maximum comparison. Okay, if the size of array is 2, again it will do the maximum comparison. Fair enough. Okay, so how we can avoid number of comparison? So best way is to understand the different problems and then come up with the solution. Okay, so let's say if algorithm, let's say we can break down this into two steps. If size of n is equal to 1 and size of n is greater than 1, there are two scenarios. Okay, n equal to 1 and n is greater than equal to 1. In both the scenarios, the important point to note is in the size, if the size is equal to 1, then array of 0 would be same as min and same as max. Okay, so the array का size 0 होता है तो min और max की value तो same ही होगी, right? There are going to be no changes in that. Fair enough, है ना? उसके बाद if the size of array is greater than 1, उस केस में क्या हो सकता है? दो probability है कि size array size is either 2 or greater than 2. Okay, see why we are doing all this? Because in case of for loop, no matter what is the size of array, you are going to go from index 0 to n. That means you will make all the possible comparison, right? To avoid this, what we can do is we can just segregate into different phases. Okay, phase 1 would be, or the part would be, if n is equal to 1, if n is equal to 2, and if n is greater than 2. So there are different scenarios in which we can handle this. So if array is, let's say, size 2, okay, size 2, then what we can do is basically we can see, let's say this is the size of array and this is consisting of 2 elements. So we can see array of 0 is greater than array of 1. If array of 0 is greater than 1, then what would be value of min? Min would be definitely array of 1 and max would be array of 0. Okay, in the other scenario, what would happen in else? Max would be, if this condition is wrong, then what would happen with max? This is basically array of 1. Min is nothing but array of 0. Simple, fair enough. But let's say if the size of array is not 0, so what will happen? It will go for this iteration, but not for all the iteration. Okay, what will happen? The iteration will start from I equal to 2. Okay, and I is less than n and I plus plus. Okay, so in this case, what is happening is we have already avoided two scenarios where size of array is 1 and size of array is 2. Okay, we can directly go ahead. So let's say if the size is 3, so it will only perform one set of comparison, right? If the size is 4, it will only perform two set of iterations. Okay, so let's modify this code and understand, okay, what we have done to do in the minimum comparison. So in this case, we will just we won't assign any values to our min or max because we are very certain what is going to be the outcome. Okay, so if n is equal to 1, in that case what will happen? Min is equal to array of 0 and max equal to array of 0. Okay, this is the case for other scenario. Okay, in the rest of the scenario, what will happen? It is definitely going to be greater than 1. Okay, so the first scenario would be, let's say the size is 2, right? So we'll just write the comment for n equal to Okay, so now for n equal to 2, what will happen? If array of 0 is greater than array of 1, then what will happen? Min would become array of 1, max would become array of 0. ठीक है, उसके बाद इन दी अदरवाइज सिनेरियो क्या होगा कि array of 0 min बनेगा and array of 1 max होगा. ठीक है, very simple, understandable. Okay, let's say the size of array is above the n equal to 2, so we don't have to do anything, just define I equal to 2. Okay, I equal to 2 and I is less than n, and we will increment the value of n after every iteration. Fair enough. Once this is done, then what will happen? Again, we'll do the same comparison, okay, which we were doing here. No change. Okay, so this is what we have done already. Now we have min or max defined. Let's get out of the else if and print them. Okay, so let's print this array. Think for the size of array, which is 5. Okay, so we have done the algorithm. So minimum is 1, maximum is 23. Okay, fair enough. Fair enough. So it's working. So we have. Okay, so let's start with the method number 4. In this method, this is also called as a tournament method. Okay, so what happens in this method? Let's understand that first with respect to theory. Then we'll code everything properly. Okay, so let's understand what happens in tournament method. So we are given the array of size 8. Okay, so 1, 9, 10, 11, 5, 4, 3, 2. So first what will happen? We will divide the array. So tournament method is nothing but a good example of divide and conquer algorithm. Okay, so divide and conquer. We'll cover in the upcoming questions what is divide and conquer based on in the later videos. For now, just understand tournament method is nothing but divide and conquer approach. So in divide and conquer, what happens? Every time we are given the array, we have to divide it into 2 parts. Okay, so how do we divide? So the first index is 0 and the last index is 7. So we call first index as left. Okay, or you can call starting index, and this we can call as h or the ending index. We find the middle point. Okay, how do we find middle point? We just sum. We just add left plus l plus h. L is the starting index, h is the ending index, and we divide them with 2. And whatever answer we get, that is the middle index or the mid index. So 0 plus 7 upon 2, which would be 3.5. And if you approximate that, it would become 3. So we have to divide array into 2 parts. So the first part, okay, the left array will range from 0 to mid, okay, or L to mid, and the right part would range from mid plus 1 comma h. So what is the L? 0, mid is 3, and for R it is 4, because 3 plus 1 is 4, and 7. So now what happens? This will be divided into 2 separate parts. The first part would become 1, 9, 10, 11, and the second part would become 5, 4, 3, 2. Fair enough. Now again, we have to divide this into 2 different parts and this into 2 different parts. So we will find the mid. So mid 0 and the 3. So mid will be 0 plus 3 upon 2, which would become 2. So first will range from 0 to 2, and the third will range from 3, 3. Okay. So sorry, 0 plus 3 would be 1. So it will be 0, say 1, and it will become 0 to 3. So now we will have element 1 and 9, 11, 10, 5, 10, 5, 4, 3, 2. Again, we will divide this into 2 different parts, which is 1, 9, 11, 10, 5, 4, 3, 2. Once we divide array into the smaller chunk, the divide part is done. Okay, as I told in the earlier divide and conquer. So divide part is done. Now we have to focus on the conquer part. Okay, so what do I mean by conquer part? Okay, so we will compare both of them and we'll come to the conclusion. Okay, so let's erase everything. Okay. So we had around 8 boxes there, right? Now we have to apply the logic of conquer. So it was 1, 9, 10, 11, 5, 4, 7, 8. Okay, let's compare both of them and see what happens. So what is the value of min? Min is 1, max is 9. Okay, similarly if you compare these two, min is 10, max is 11. If you compare both of them, min is 4, max is 5. If you compare these two, you will get min equal to 7, max equal to 8. Okay, now again you have two values, compare both of them. Out of these two, definitely min is 1 and max is 11. Okay, compare these two, min is 4, max is definitely 8. Okay, compare both of them, min is 1, max is 11. So at the end we will get the output. Okay, so we first divide them till we reach the first element. Once the division is done, what we do is basically we get min and max. Okay, so let's code this out. Okay, to code this out, we'll be using the very special data structure called struct. I don't generally prefer complex data structure or the advanced data structure such as struct, but for this problem we will have to use, because in C++ you can't return two variables as an output in the function. For example, if you have noticed, like in a simple example, let's say you have defined a function called add. So you can pass as many as input you want, right? A2, A3, A4, A5. But at the end, you can only return the only one output, which is result. You can't return result 1, result 2, result 3. Unlike other programming languages, to achieve that, we have to use struct. Okay, to achieve this objective. Okay, so don't worry, I'll just give you the basic understanding about struct before we start. It's very simple. So what happened in struct? Let's understand with the help of theory. So struct is simple. Use this keyword called struct and to define the variable name. Okay, so in our case we'll define pair, and inside the pair we will just write the values inside the pair. So we have to find min and max. So I'll just write min and max. And again you can define the type of these variables, int min, int max, because at the end they are the int, right? So struct pair. Once this is done, you can just use them as and you can just use them wherever you want to use them. Fair enough? Okay, let's go ahead and implement this. It's very simple. So first thing first, we have commented the previously written code. Now we will define the structure or struct, which is pair. Okay, now we will define min and max. Okay, now once we have defined the min and max, we have to define one more function. Okay, and this function will help us to get a pair. Okay, get min max. So we will pass array here, okay, as an input, and we will also pass the starting index. Okay, let's define L and the ending index, which we can call low and high. Okay, and at the end, let's see what happens. And what we have to do is, for every array, what we have to do is we have to find the value of mid, right? Because we have to divide them. How do we find value of min? Is L plus H, right? L plus H divided by 2. Once we have value of mid, what we have to do is basically divide array into two half. Okay, to do that we have to use our struct. We will just define three variables: min, max. Okay, so this min max is nothing but the struct object which will consist the value of min and max, which we have to return at the end of this function. This LMM is nothing but left min max, and RMM is nothing but right min max. So as you have seen, when we divide array into two different smaller or sub arrays, there is one right array and there is one left array. Okay, right and the left array. Understood? So these two variables LMM and RMM will hold the respective min and max of those arrays. Okay, so let's get left mm. So how we will get? We'll pass this function get min max. Okay, what this function will do is it will pass array. It will pass the lowest value and the value of mid, as we seen in the example or the theory before this. Then we will just pass RMM. Okay, we will pass RMM, and we will see which one is better, which one is not. Okay, again we will pass array, we will pass mid plus 1, and we will pass H. Okay, fair enough. Once we have left. Okay, so once we have L, MM and RMM, so both of them will have max and min values of the respective sub arrays. Okay, max and min, but we have to give the minimum or maximum of the whole array, right, at the end of the day. So what we will do, we will compare the max of left and the right with each other, and we will just mix the answer here. We'll compare the minimum of both the arrays, we'll combine them here, and we'll get the overall minimum and overall maximum. Fair enough? And how do we do that is again basic if and else. So we will just refer left max if the maximum of left subarray is greater than maximum of right subarray, we will assign min max dot max equal to left subarray का max. ठीक है? If it is not greater, then definitely min max का जो max होगा वो assign होगा किसको? right subarray के max को. ठीक है? अब सेम चीज हमें किसके लिए करनी है, सेम चीज हमें किसके लिए करनी है, मीन के लिए करनी है, ठीक है। इफ द लेफ्ट एरे का मिनिमम इज लेस देन राइट एरे का मिनिमम, ओके, तो यहाँ पे क्या होगा, हम असाइन करेंगे किसको, मीन मिनिमम को किससे, लेफ्ट एरे के मिनिमम से, ठीक है। अदरवाइज विल डू द रिवर्स और द अदर साइड, okay. So we have min max at the end, okay. So now let's return this. So what we will return is min max. Now min max is what, min max is nothing but the struct, okay, and with the help of struct we can return two object or two values, min and max. So as you have seen, this is serving the same objective. Now let's do one thing, let's just copy this code of which, you know, whatever was inside min, so that we don't have to write it again, okay. So let's uncomment this. Why I'm copying this, because I don't want to rewrite what I have already written, right? So we won't be doing all this again. All we just need is this, okay. So we just have to call what, struct min max, struct pair min max equal to get min max, okay. Get min max array comma the lowest index and the highest index, right? So what is the highest index, n minus 1, fair enough. So we have min max, so what we have to do is basically min max dot min max dot max, fair enough, okay. Now we have worked on the divided part, okay. Let's see how the conquer part will work, okay. So what we had seen in the conquer part, we divide the array until it becomes the single arrays, okay. So at the end we get around 8 single elements, okay. Then we compare both of them, and then we compare both of them, and then we compare the sum of previous two sub arrays, okay. And similarly we compare this and we get some two values, okay. Fair enough. Let's do that. Let's do what, if the size of array is 1, then what will happen, if the size of array is 2, then what will happen. So once the element is divided so much so it is only 1, then what will happen, once there are two arrays, then what will happen, okay. So let's see what is the condition when the size of array is 1, okay. So if array of L is also equal to array of H, then what will happen, min max dot min would become array of L, min max dot max would become array of L, okay. So you might be thinking ऐसे क्यों किया, ठीक है, तो देखते हैं क्यों किया हमने इसको ऐसे, ओके. सो यार अगर एक एरे है तो इसमें मीन भी सेम ही होगा, राइट. अगर एक एलिमेंट है मतलब उसमें मैक्स भी सेम ही होगा, राइट. तो 9 ही होगा, 9 ही होगा. हमको फाइंड कैसे करना है कि एरे 1 है. तो अगर एरे का लेफ्ट इंडेक्स और राइट इंडेक्स दोनों सेम हो, इफ एरे का लेफ्ट इंडेक्स और राइट इंडेक्स सेम हो, तो उसमें क्या होगा, उस केस में वो एरे. सो आई थिंक मेरी कंडीशन रॉन्ग है. रॉन्ग इस टर्म्स में है कि मैंने एरे ऑफ लेंथ, एरे एट एच, एरे एट एल लिया, जबकि मुझे लिखना क्या चाहिए था एग्जैक्टली. सो what we have to do is basically if L is equal to H, okay, if L is equal to H, then we will go for this condition. So let's repeat once again. So L is equal to H, मतलब अगर यहाँ पे एक ही एरे है उसमें 9 एलिमेंट है तो इसका L भी 0 होगा और इसका H भी 0 होगा, राइट. इसलिए L is equal to H and there is no other scenario where L is equal to H. Fair enough. Good. Now let's see the condition for this condition, okay, because there are majorly two conditions out there. One, the array is single, so we have already covered that. This is the code for that. One, there are two elements, then what happens, okay, because at the end there will be two elements to compare, okay, except the first time when we compare it with the itself, okay, when we do the self comparison. Fair. Let's do that. So how we will find there are two arrays, okay. So again, a very important thing, when there is a two arrays, then what will happen, let's understand with the help of one more array. Let's say there are two arrays, okay. So L is equal to 0, H is equal to 1. Fair enough. Let's talk about the other scenarios, okay, when there are two elements and value of L is different and H is different. There is no other scenario, okay. So whenever the element, there are two elements in the array, the value of L would be 0 and H would be 1. So if I have to consider this condition, so I can come up with the logic. If I minus H minus L, I'll get answer 1, okay. If this is the condition true, then we have two elements in the array. Fair enough. If I subtract high minus low, I'll get 1. If this condition is true, that means I have only two elements in the array, ठीक है. तो इसको अभी हम कोड के थ्रू करते हैं. बट इसमें एक चीज़ और अंडरस्टैंड करते हैं कि अगर मुझे मालूम पड़ गया हाँ कंडीशन ये है, इसके बाद नेक्स्ट स्टेप क्या होगा, नेक्स्ट एक्शनेबल क्या होगा इन टर्म्स ऑफ हम क्या करेंगे. तो इफ देयर आर टू वैल्यूज इन द एरे, देन इट्स वेरी सिंपल, राइट. विल कंपेयर एरे ऑफ L विथ एरे ऑफ H. इफ एरे ऑफ L इज ग्रेटर देन नेक्स्ट क्या होगा, एरे ऑफ L होगा, एंड मिनिमम क्या होगा, एरे ऑफ H होगा. अगर ये फॉल्स रहा तो क्या होगा,
max would be array of H, min would be array of L. So this is very simple in terms of the execution. Let's implement this in the code and see what happens. If H minus L is equal to 1, okay, then what would happen? If array of L greater than array of H, then min max dot max would become array of L, because array of L is greater, right? Min max dot min would become array of H because ये बड़ा है, ठीक है. और इन दी वैसा वैसा क्या होगा कि हम इसका अपोजिट ले लेंगे, ठीक है, ठीक है. Fair enough. So I guess we have done that. ठीक है, तो let's run this code and see whether we are getting the output or not. Okay. So as you can see, we have run it and it worked like a magic. So let's go ahead. So that's it, everyone. That's it for the second question. So we have covered 2-3 methods. So you can go through the video if you like the video. Do subscribe us, like our video, and you can ask your questions in the comment section. I'll attach the solution code in the description. You can check that out.